In this example, we're asked to graph the linear inequality. Notice we have only one variable, which indicates this is probably going to be a vertical or horizontal line. In terms of determining which one it is, this is an x, which telling you you're going to pass through the x-axis. And when you pass through x, you're going to pass vertically, because when you pass through it, you're going the opposite direction of the x-axis. Here's the x-axis. The opposite direction would be passing through it, and that's a vertical line at -4. Vertical line at -4. What type of line? Is it solid or dashed? That's correct. It's a dashed line. So now we want to determine, do I shade the left of that line, that little small little sliver there? Or do we shade to the right of the line where the test region is? Well, let's go ahead and plug in the zeros. We don't have y, so we don't need to worry about y, but we're going to go ahead and plug in a 0 for x. So when we plug in a 0 for x into the original equation, we're going to read the statement. 0 is greater than -4. That is a true statement because 0 is bigger than your negatives. So therefore, that was over where the test point of 0, 0 was. So that means that you would shade to the right of that vertical line because that would be your true region. Let's go ahead and do another example. In this example, we're asked to graph the linear inequality, and again, we only have one variable. However, we need to solve for that variable, get that variable by itself and our numbers on the other side. So the first thing I need to do is to subtract 2 from each side. Now that we've rewritten the equation, we can go ahead and proceed with graphing our line. And we can see that we have a line underneath there, greater than or equal to, which means we're going to sketch a solid line that passes through the y-axis at -2. So if this is the y-axis, the vertical line, to pass through it, you have to go in the opposite direction. Passing through the y-axis at -2 would be a horizontal line going through -2. And yes, that is going to be a solid line. Now, as far as which region we're going to shade, whether it's the upper boundary or the lower boundary, remember the boundary method. If you have here a greater than, when it's in this form, solve for y, then that means that you would shade the upper region. If we're using the test point region, our test point would be at 0, 0, so we're going to remove the y because we don't have an x and replace it with 0. If when we plug 0 in, if it leaves us with a true statement, then we would shade over the region where the test point is. So let's go ahead and plug it in. When we plug that in, we are left with the statement that 0 is greater than -2, and that is true. So that means that yes, you would shade the upper region. So there I showed you how you could use the boundary method to determine that yes, you would shade the upper boundary, or you can use the test point method. And the statement here is true, which again means that yes, you would shade that region where the test point is. And there you have it.